Hi, everybody. In this 7, we're going to play around with some probability formulas that we've learned over the past 2 weeks. So let's review something that we ended with on the last lesson. So randomly choose an adult from the United States. We'll define the event A as the person is male and the event B as the person is pregnant. So are the events A and B mutually exclusive? So if I was to draw a Venn diagram for this, here are all the men. Let's keep it in the circle. Here are all the men in America. And over here are all the pregnant people. So what do you notice about these two circles? They don't intersect like they normally do. So the probability of A and B, is 0. So what this tells us is since there's no intersection, there's no and, there's no both, there's no intersection, these events are mutually exclusive. Mutually exclusive. Mutually exclusive means they both cannot occur. The and probability equals 0. Both cannot occur at the same time. So what does that have to do with independence? So if I try to find, if I want to do pregnant given male, well, the formula is male goes on the bottom, so that's 50% of the world. Well, the and probability goes up top, which we just said was 0. So the probability of pregnant given male is 0. So are these events independent? Well, no, because that doesn't equal the probability of someone being pregnant. There's not 0% of the world that is pregnant right now. So these events are not independent. They are not independent. And that's going to happen every time. If you're mutually exclusive, you cannot be independent. They're two different ideas, but you got to make sure you get them organized. Independence means they don't affect each other. They don't change the probability of the other one occurring. Mutually exclusive just means they both cannot occur. So let's play around with that a little bit more. So we defined what A with the little c means. This is the complement. This is the complement of A. The complement of A, which means the opposite of it. So let A be the event that a particular flight is on time, where P of A is 0.78. Well, what's P of A complement? What's the probability of not A? Well, what's the opposite? There's a 78% chance it does occur. What's the opposite of that? 0.22. What is the meaning of this? This is the probability that a particular flight is not on time. Remember that complement there means not. So the big idea here, if I want to find the complement of an event, the probability of A complement is 1 minus the probability of A. It's the opposite of the probability of A occurring because together they need to make 1. Explain why they're mutually exclusive. So A and A complement are mutually exclusive. Why? Why are they mutually exclusive? You cannot have A and not A happening at the same time. That's impossible. By definition, if A is happening, not A cannot happen. If not A is happening, A won't happen. So it just makes common sense that A and not A cannot occur at the same time. The probability of A intersect A complement is 0. If I was to draw a Venn diagram, here's A. A complement is everyone outside of that circle. Notice there's no overlap. Their intersection of inside that circle and outside that circle is 0. So mutually exclusive. Two events are mutually exclusive. They are disjoint if there's no intersection, if the intersection is 0. It's just a vocab word that I might throw around over the next week. Let's practice now. Everything else we do from this lesson here on out is just practice. So when a room is randomly selected in a downtown hotel, the probability that has a king-size bed is 62. So the probability, I'm going to make a little cheat sheet here. Probability of king is 0.62. The probability it has a view of the town square is 43. And the probability it has a king and the view, so it's an and probability, is 0.38. All right, so king is actually A, and the view is actually B. Create a Venn diagram. I can do that. I've got A, and then I've got B. So remember, this whole A circle is 62%. This whole B circle is 43%. I can put the intersection in, though. And now it's just subtraction. This entire circle is 62%. I've used up 38 in the middle there. So if I subtract, just grab my TI-84, I get 24% is just A and not B, just A. And then subtraction on the other side gives me 0.05. And now there's one more piece that's left over, the outsiders. What's the complement of what I used up right now? So let me add those guys together and do the opposite of that. I used up 67. These guys together is 0.67. So the complement of that is 0.33. So here I say find the probability of A given B. What is the probability of A given B already happened? Well, that means B became my denominator. This entire B circle became my denominator. Well, what part of B is A? So my universe shrunk. I'm only allowed to pick from this circle. What part of this circle is A? Well, 0.38. It's the and probability over the given to the nearest tenth of a percent. So 0.38 divided by 0.43 is 88.4% or 0.884. So what's the probability in the meaning of this context? So in the context of this problem, I was given B. I was given a view. Given a room has a view of the town square. I was given that. Given a room has the view of the town square. Given I have a view of the town square, the probability of randomly choosing a king-size bed, because that's what A is, a king-sized bed, is 88.4%. Knowing I have a view means there's an 88.4% chance of me having a king-size bed. Are the events A and B independent? Does knowing one occurred affect the probability? So, well, let's look at this. The probability of A, which is the king-size bed, is 62. There's a 62% chance I pick a room with a king-size bed. But the probability of me picking a king-size bed given it has a view was 88.4, so 0.884. These are not equal. These probabilities do not equal each other, so they are not independent. They are not independent because the probability of A does not equal the probability of A given B. Knowing you have a view affects the chance of you finding a room with a king-size bed. It makes it more likely to occur. Quick little side note here. You could have also done probability of A times the probability of B. So king-size bed times the view was 43%. I could find this product, and notice it does not equal the middle. This does not equal the intersection. So they are not independent. That's your other way to do it, is find the product of the two circles, 0.62 times 0.43, and say, does that equal the and probability? In this case, it does not. All right, we got one more problem, and then we are done with this lesson, short and sweet. So a credit card company states that 42% are long-term card holders. Long-term is 42%. 35 pay their bill in full. So the probability they pay their bill in full is 35%. And 23% are long-term card holders and they pay their bill in full. So long-term and pay in full is 23%. Let's make a Venn diagram for this. I've got long-term and full. So remember, this entire long-term circle is 42%. The entire full circle is 35%. We struggled with this. The intersection is 23. So you subtract to figure out the rest of these pieces. 0.42 minus 0.23. 19% are just L. 12% are just F. So that gives me, how much have I used up so far? What's my OR probability? So far I've used up 54. So what's the complement of that? What's left over for my outsiders? 46% are neither. 46% don't fill in either of those categories. So compute the following probabilities. The probability of L given F. So I'm only allowed to pick from the F's. F was my given. My universe shrunk there to that 35%. I'm only allowed to pick from these people here. Well, how many of these people are L's? What's the probability of picking an L from that circle? Well, it's 23 out of 35. 23 out of 35. That comes out to be 0.657. Well, let's switch it around now. Let's do F given L. So my universe shrunk to the L circle. I'm only allowed to pick the L's, which is 0.42. And of that 0.42, how many of them are also F's? Well, 23. So notice how the numerator is always the and, but the denominator depends on what we're given. So a conditional probability uses our and formula and divides it by whatever information was given. 0.54 rounded up to 8. So that conditional probability and over the given is still in effect. Are they independent? Well, we have two tests for this. I can do the probability of L. What's the probability of L? 42. What's the probability of L given F occurred? So I'm comparing this condition now. That condition increased the probability. It made it more likely. So they are not independent because knowing they pay their bill in full means it's more likely that I'm picking a long-time cardholder. So they are not independent because that F, that condition, affected the probability. So they are not independent because why? P of L does not equal P of L given F. The other test is the multiplication test. We find the product, L times F. The L circle is 42. The F circle was 35. We find that product, 0.42 times 0.35. And we hope we get the middle. We hope we get the middle, and I get 0.147. The middle is 23. The probability of L and F is 0.23. These are not equal. These are not equal, so they are not independent. If they're the same, then they are independent. But since they're not the same, they are not. It's just using this formula in a different way. So that's how you test for independence. That's how you test for independence. If two events are independent, we can compute the and. I'll end on this note here. If they're independent, so I'm assuming they're independent, how do I get and? Well, I find the product. You can only find the product if you had independence to start with. That's a requirement before you start multiplying. So the product gives us the and probability. If and only if they're independent. You have to have independence because here, when you multiplied them, you didn't get the middle. You didn't get the middle because they were not independent. So that's the condition. If they're independent, you can find their product of A and B, the probability of A times the probability of B, and you get the intersection. All right, guys, I'll see you in the next lesson.